Okay, so we are going to apply what we did in the cosine challenge to solve this equation. 2 cosine theta plus the square root of 2 equals 0. This time we have an interval from 0 to 360 degrees, which is nice because we don't have to think about every single possible answer like in the first one because there's infinitely many answers, but for this one, limited number of answers, thank goodness. Okay, so I have 2 cosine theta plus the square root of 2 equals 0. First thing you want to do is isolate your trig ratio. So I'm going to subtract the square root of 2 from both sides. So I have 2 cosine theta equals negative square root of 2. Then to isolate cosine completely, I'm going to divide by 2. So cosine theta equals negative square root of 2 over 2. And I recognize that as the same thing as negative 1 over root 2, which comes from my special 45, 45, 90 triangles. So if I draw my quadrant out, I know cosine has to be negative. So if I write out all students take calculus, all of them are positive here, cosine is positive here, so that means cosine would be negative in this quadrant, so that's going to be one solution. Cosine is also going to be negative in this quadrant. Notice that both those quadrants, whenever you put the angle in, the adjacent side would be going negatively. Okay, so I know I need a 45, 45, 90 triangle. Anytime you see square root of 2, that's kind of your key, 45, 45, 90. So put 45 degrees here. I've got negative 1, 1, root 2. So this gives us an angle, it almost goes to 180, but it's 45 degrees short. So I do 180 minus 45, and one of my solutions is 135 degrees. Okay, now I go down here to this one, and this is 45 degrees again, because I'd have 1, this would be negative 1, root 2. So when you're thinking about cosine, it'd be negative 1 over root 2, which is negative root 2 over 2. So from here, I was at 180 and I went 45 degrees forward. So 180 plus 45 is 225 degrees. And so those are my final two answers, are 135 degrees and 225 degrees.